Hello everybody and welcome to the latest edition of the Founders Playbook from Lab to Launch, where you hear real stories from real people. You can learn real lessons of how to make a business work in the real world. Because let's be honest, the typical startup advice doesn't work for deep tech founders. You can't just move fast and break things when your product has been developed over a decade of peer-reviewed research. You can't just follow the Silicon Valley playbook when you're navigating intellectual property with a university and trying to find capital for hard tech in a capital-constrained world. So where you get the real answers from is from someone who's actually done it. And our guest today is one such, Adrian Pugsley, founder of Switchable Insulation Innovations Limited. He's lived through the entire lab to launch journey, developing their technology, the search for that first believer, and the challenge of turning complex research into a product someone will actually pay for. So if you're an academic thinking of making the leap, this is the conversation you've been waiting for. Adrian, hello, how are you? Good to see you.
I'm good, Neil. Thanks for having me. Looking forward to it.
All right, and you're talking to us today from what looks like brand new purpose-built facilities. Where are you coming from today?
It is indeed. So I'm based in the Ulster University campus in Belfast, a new £350 million city centre campus building, which is a wonderful place to work and a great environment for launching our spin-out.
Fantastic. It just goes to show how much support there is going in right now in the UK into developing all these new technologies. So let me start, if I can, by start trying to understand a little bit about where you've come from. Who is Adrian? Why is he doing this? Because before you were the founder of Switchable Insulation, you've had a previous life. You're not someone that's come through university straight away. You've been, I believe it was an engineering project manager, and also you've done that research at university. Give us the story. What got you to where you've come from?
I worked for 10 years as a consultant in the construction industry, looking at acoustics in buildings, advising architects on noise control. I got very interested in green buildings and the whole challenge around energy use. I did a PhD in solar energy, looking at building integrated solar water heaters. The simplest version of that is to paint a metal tank black, fill it full of water, leave it out in the sun. We don't have the sunny weather. So what my co-founder, Dr. Mervyn Smith, came up with was something called a thermal diode. It allows heat to go into that tank from the sun, and then it blocks that heat from being lost overnight. This was in the sort of mid-2000s. And around about that time, something called solar photovoltaics, which everybody probably knows of as solar panels, started to get very, very popular and very, very cheap. So we had this technology, the thermal diode, looking at thermal diodes at a market that was basically saying, we don't really need thermal diodes because there's no market for solar water heaters anymore. So we were scratching our heads for what we could do with this thermal diode technology. My background as a consulting engineer before I came back into academia, a lot of my time was spent working on the design of facades of buildings, looking at things like noise control. And there's an interesting interplay between how you ventilate a building and how you insulate a building. Can you open windows in a busy urban environment? No, because if you're trying to sleep and there's a big road outside, you need to shut the window. If you shut the window, you need an alternative way of ventilating the building. There's a similar interplay with insulation in buildings in terms of keeping heat in or keeping heat out. And this is where the thermal diode ideas crystallize into, right, well, rather than this device for a solar water heater, can we use this in the facade of buildings to solve problems? There's increasingly a problem with overheating. So what we're able to do with the thermal diode idea was to turn that into something called switchable insulation. You can have all the benefits of insulating a building in the winter, keep heat in the building, but switch that insulation off in the summer to let heat out again to stop you overheating.
There was a technology that was existing, but actually it had almost lost its purpose. It was sitting there ready to use. There was also something about your experience, both pre-university and understanding how the building trade worked, looking at a problem that you discovered when you were looking at buildings. There's insulation, but there's not only just that from noise and the facades and understanding that, but also thinking about it in terms of solving the problem of heat and cooling and bringing all those three elements together somehow.
We're saving energy in the winter a little bit by insulating, but then we're increasing our energy use in the summer because we're having to air condition buildings that shouldn't need to be air conditioned. This is particularly a problem when you have urban environments where you've got noise and you can't, for example, open a window to let that heat out. So if you've got a sealed building, you've no way of getting rid of that heat other than to air condition or use switchable insulation.
What happened to make you think, hold on a minute, there might be a commercial product here? Was it a single event? Was it a slow realization? How did all these things coalesce into saying we can do something?
And I started off with the PhD in 2013. There was quite a buoyant situation in terms of research funding at that time. I sidestepped a little bit, started looking at solar PV and batteries, and doing some work in Botswana, looking at electrification for rural villages, and particularly, wanted to get the thermal out into the world to do something useful. So I spent so much time sort of working on it. During my first year of lecturing, an opportunity came up, the Innovate UK iCure program. So the iCure program is particularly intended to take research from universities and give it a platform in the commercial world, and to go out. It's grant offering for academics to go out and talk to people in industry to try and find a customer base and use for technology developed in universities. So that was really the thing that sparked this commercial journey. The opportunity of iCure funding was my sort of route to being able to continue the journey that I'd started in the PhD. It was almost last chance saloon. You spend so much time developing a technology, and you can take it to a certain point where you could keep iterating forever, but without some commercial impetus, that you're sort of nothing to guide the direction of that research journey. So it came at the perfect time. Go out, talk to industry, and understand where this thing can fit. Is there an appetite in the construction industry for this type of technology, for this type of solution? Effectively.
Interesting. It feels like there was a search going on anyway. In the way that you're talking about everything from batteries to Botswana, you were looking for an outlet, but then that commercial impetus, is it useful? But also that support system. So iCure, many people that you and I both know have been through that process, just to give a first idea of, would this actually be of any use to anybody? And giving you the feedback is really, really important. It's not just about technology, it's about the commercial feedback. You've come through, you've got a technology, you think it'll work, you're talking to people in iCure. Translating that academic work into a startup is a huge leap. You were in academia, you were comfortable, you could have carried on as a lecturer, you wanted to make something real in the world. Was there anything else that pushed you to leave that relative safety of academia and become an entrepreneur?
The entrepreneurship appealed to me, partly because I wanted to build on the academic work that I'd done, but I also yearned for the connection back to the industry that I was working in before academia. It just seemed like the perfect way to tie up those two previous career strands into something new. And it's a decision I really don't regret. It's been a fantastic journey and continues to be so, even with the fact that there's a lot more uncertainty associated with entrepreneurship than a regular salaried job. I pay my own salary, and if I don't get money in to pay for that salary, I won't get paid. It's working well at the moment.
Lovely. And so melding those different parts of yourself, it's a really common theme. So you were working very much with your co-founder now. What's his full name?
Dr. Mervyn Smith. He's a brilliant character. He's a very practically focused person. In fact, he's at the moment in the lab. In the summer, he tends to do a lot of lab work. He's really hands-on. He's in the lab doing some tests on some of our panels with one of his students. He's also a highly skilled welder, which is brilliant for us because a lot of our work is based on prototyping. I'm quite a data-driven person. Data analysis and modeling side of things. Mervyn's expertise is in building services engineering, ventilation, whereas my sort of background is more in the sort of envelope, the facade of the building, and the acoustics. But we are both engineers. Actually, in terms of our team and building the team, the area which we really are going to need to work on is actually getting somebody with that real commercial experience in the construction industry. We both understand the industry quite well, but we've always been on the engineering end of it rather than the commercial end. That's our sort of next mission in expanding our team, is to get somebody commercial with that background.
So did you got to know Mervyn in the course of your PhD and just got on and were thinking in certain ways? Was that just natural progression?
Absolutely, yeah. So Mervyn was one of my PhD supervisors, and we worked pretty closely during the PhD, and then afterwards, pretty much most of my research I've done has been with him. Increasingly, it's gone from it all being driven by Mervyn to now being more driven by me as we've moved into the commercial area. Things like grant funding applications and going out and finding customers all moved into my sphere rather than his.
You're talking about bringing people that are more commercial into the team. Is it just you two right now, or is there anybody else working with you?
Our board is myself and Mervyn, and our TTO from Ulster University, Fergus Begley. I'm taking the CEO role. I'm sort of dealing with almost all of the day-to-day management. Mervyn takes the chief technical officer role. Fergus is really more there as a non-executive director, more of an advisor. We've also got quite a few staff working for us. We've got Marcio Navias, who is our prototyping engineer. He's a very talented craftsman. We've also got two business development associates as well. We've got Stephen McComb, who has worked in a number of different spin-outs. He sort of drives a lot of the sort of strategy and guiding me through this transition away from academia. He's got a lot of expertise in lean management. My other colleague Mazem, he's been taking the charge of going out there and trying to find us customers and actually keeping the world abreast of what we're doing newsletters and LinkedIn posts and maintaining that front-end business development. I've also got two more part-time former students of mine basically dealing with energy modelling work associated with switchable insulation and looking at, what is the bang for buck of installing the product in a building, trying to get some proper numbers against how much this thing will cost and how much energy will it save. And the last shout out would go to Michael, our accountant. I do most of our actual financial work, but he basically keeps me in check and makes sure I'm not doing anything that I shouldn't be.
What's interesting about hearing you talk about all those people is, firstly, as you say, you're a startup, you're still working on grant and investment capital. And secondly, where they are all coming from. There's quite a lot of that university support still there. You've got the TTO on board. Some of them are coming through the university, other people you've found and hired. You've looked quite broad and looked at all the sources of support and talent you can find. You've built a team that's doing a lot of different stuff. You can't just rely on one source.
We're always working on a 6-month horizon. We're also based in Northern Ireland. It's a relatively small pool of people anyway, a couple of million people. But it works well. There's a big benefit in getting people that you know, because you know what they're capable of, and you can have some quite frank conversations about what needs to be done. If there's a pinch point of a deadline, we've just got to get this done. Being able to get stuff done quickly with a lot of trust works really well.
And again, that's something you'll hear from a lot of entrepreneurial companies, right? It's different from running a corporate. You haven't got an HR department. You don't have a massive budget for processing people through, and you need something now because we've just won the grant and we need to spin up because we've got to get going in 3 weeks' time.
Exactly. Time. We don't have time. You can't spend 3 months, 6 months finding somebody, because by that time the money is gone.
Right. So you've got a team. You've got a co-founder that you got to know, and you develop the ideas together. So outside of academia, outside of yourself and Mervyn in the lab, who was your first believer? Who was the people that said, actually, guys, you're off you go. This could work? Who outside of the bubble made you think, yeah, maybe we can do this?
This brings us neatly to the iCure program. So it was a really, really intense 3-month period where I was flying around all over the place, spending a lot of time on Zoom and on Teams and LinkedIn and on the phone and emailing people, basically to go out and tell the world about what Mervyn and I had been working on, tell the world about switchable insulation, the idea and what our vision was. I think it was around about 80 different companies we spoke to. So Mervyn in the university looks after all the student placements. He's got an incredible network of people that are former students of 10, 20 years ago who are now the sort of big names in industry and building services engineering and in facade engineering. A key person in that is Will Stevens, who owns a company called Interface Facade Engineering based in London. And he opened up a massive network to us of pretty much all of the UK's facade engineers, big name companies like Mott MacDonald and Arups and Kears and a lot of the big consulting engineering construction firms. The three things that they told us. One was that our insulation performance of our panel had to be 0.2 watts per meter squared Kelvin. So 0.2 or lower. There's a lot of emphasis on lower, and lower in that value means better insulating. So that was the first thing, was a performance target. The second one was a price point. And the price point is really thinking about what would people in the industry balk at if it was more expensive than, and what would they bite your hand off for if it was cheaper than. And so we ended up with a number there of around £200 a metre squared for the product. Ideally lower, the cheaper it is, the wider the applicability. But it's nice to know that that's a number that there was a consensus on. And the third one was about this practicability of actually installing this in the facade of a building, and that was to do with the need to have a clear cavity in the product. And that was something which made sense when we were told it, but we hadn't really thought it through until we'd had these conversations. So yeah, really useful conversations we had, but also a lot of encouragement. They'll have a target for how much the running costs of that building is going to be in terms of the energy bills. And it's really is helping that challenge of reducing those energy bills, which not only affects the engineers, the designers who we went to initially because they're the ones that speak our language, but then they're spreading the word on to their customers, who are developers who are paying for this thing at the end of the day.
Really interesting. So firstly, what I heard was that there was somebody who was very useful to you in linking you up with different people to talk to. So the networking, however you do it, whether you know the people or whether somebody else that's helping you knows the people, you've got to be able to talk to all those different people to get that feedback. Then I think you became an engineer, a consultant again, because I heard performance, price, practicality.
Yeah.
Right. And then I heard when we start to tell them what it does, not what it is, not how you've developed it, but what it does. So it sounds to me like you've really had a very practical, actually business impact head on your shoulders when you were having those conversations, because that's how you're expressing it now. Performance, price, practicality. That's what they care about. They don't care about how it works. They care about what it does.
The only thing they care about how it works is whether or not it's going to break. that was also a big part of the conversation here. And this is something particular to facade engineering, that you put the wall of a building up. The building is expected to last 100, 200, 500 years. 50 years is a sort of minimum most of the time. And in that 50 years, you really don't want to be having to put scaffolding up to actually go and replace bits of facade. The facade needs to work for the life of that building with really minimal maintenance.
So you knew it, but you also checked it. And you had a good level of feedback on, these were our assumptions. This is what we thought was happening. And actually, people are telling us the same thing. You've gone and spoken to people. You've got a bit of validation. Yeah, this could work. But of course, that's in the lab. So what was the biggest technical hurdle you had to overcome to prove that this was a viable product and not just a science project?
So the insulation bit, we understand pretty well. The switching part is the part which is the more challenging technically. To do that, we have had to create, I don't want to say too much because of patents and such like, but we've had to create a valving arrangement that controls liquid vapor flow within the insulation. Taking that from an idea to something in the lab to something that can go outside onto a real building, that's probably the deepest physical deep tech challenge. We're on Mark 15 of our panels, and we're at that point now where we've got prototypes out in the field. We've got 2 or 3 field trials running at the moment, one in Belfast here and with a local construction company called Farron's who work a lot in England. We've also got prototypes on a construction site near Reading. And that journey, this is the thing about deep tech, and I think you mentioned at the start in the introduction, there's a big difference between creating an app that does something where once you've got the idea and you've got a plan for how that's going to work, you can actually realize it probably very quickly. You can throw a lot of software coders and developers at something and produce a product pretty quickly. We're in a different realm altogether. We've got to sort of physically get something to work in a lab. Then we have to take it outside. Does it work outside? Change the design a bit, get it to work outside, and then get it into outside with real people using it. There's always different things that you discover, and every one of those steps, TRL 4, 5, 6, 7, all of those steps, we're discovering new things each time we change that context of how we're testing it. We need to test something in summer, winter, and spring/autumn, so you've always got sort of at least 6 months to get a decent outdoor test. We also have the challenge of when we're dealing with real buildings, you've got people, you've got safety, you've got permissions, you've got reliability, you've got convincing somebody to let you test it in their building. The other big challenge is on the virtual. So the virtual, and this, if I look back in time, look back with hindsight, this is the one probably that we should have put a lot of effort into probably 2 or 3 years ago before we spun out. So the virtual side of this is really coming down to the value proposition of what our product does, what can it achieve, what's the cost saving that it can yield. So we've got a product that goes in the facade of a building. It lets heat into the building when you want it to, in the winter when you need heat, and then heat out in the summer if you've trapped too much heat. You then have the big question of where is that most useful? And how much energy will it save? The where is which facade of the building is it on? Does it face east or west or south or north? And quantifying what the energy saving is and whether you can avoid having to have cooling equipment. Those questions are, fundamental to what the value to the end user is. They need to have that quantified. How many kilowatt hours is this going to save me per year? Kilowatt hours turns into pounds and pence, but all of the commercial software for modeling energy in buildings does not have a way of switching insulation on and off. And this has two problems for us. One is whenever we're trying to evaluate what the saving is, we have to build a very bespoke model to calculate what the saving is going to be. And the second problem is that when somebody is designing a building, they need to be able to know very quickly what the benefit of using the product is, how much of the product they should use, and where they should put the product. So there's a real need for a modeling tool to support our product, almost as a sales tool for us, but actually as a tool to quantify what the benefit is. We didn't really realize just how important that was until really quite recently.
Well, it's really important because as you were talking earlier about practicality as well as price and performance, and practicality is, does it fit what you're trying to fit it into? And part of fitting what you're trying to fit it into is not just, does it fit on that wall? It's, does it fit the commercial business models of what people rely on in the companies you're selling it to and through? If you need to fit into their systems of, how do we validate this thing? How do we test it? How do we know if it's going to work? And that's the problem you're hitting right now, is how do we give them something they trust? And that's absolutely vital to make something work in an ecosystem. And what's also interesting is how you're talking now is about how important thinking through those commercial validations are in parallel with developing what you're developing.
Yes. Yeah, absolutely. And as I say, there's a lot of sort of hindsight to this. It all seems very obvious now that that's what we need. Couple of years ago, we sort of had a sort of risk register. We had a sort of list of things that we needed to do. It was always on the list, but its relevance and importance when we put it on the list initially was quite low. Whereas now we know that is fundamentally the thing we need to get right.
Really important. Really important for people to hear when they're in university. Don't just focus on the tech, also focus on the market as you're doing it. Okay. You did mention patents before, because obviously, as you were describing what it is that you do, you've got to be really careful not to invalidate your own patent. When did you start thinking about what you've got as intellectual property, and what was your strategy? Did you patent straight away? Have you licensed from the university? What's your intellectual property strategy?
The university has paid for the patenting process, so we filed our UK PO in January 2024. We then converted that into a European patent application in January of this year. The IP was developed within the university, so the university owns that IP. So we've got a royalty-free exclusive license to the university's IP, which will be granted to the company when we onboard investment. So at the moment, the university is a shareholder, and our working capital as a company came from the university from a convertible loan. We've been working for the last year as a company on furthering that IP, and most of that IP is therefore the company's IP rather than the university's IP. So then we have to sort of think about how does our own patent dovetail in terms of ownership with the original IP, which is still sort of going through the patenting process. So there's a sort of complex sort of navigation that we're going through where, we want to maintain that link with the university, that they're really important for our existence, but also making sure that the company remains attractive to outside investment. The investors want us to own the IP. Therefore, when they buy into the company, they buy into the IP directly rather than buying into a license. It's a tricky one to navigate, but our agreement with the university really is that if we can raise the investment, then we get the IP transferred to the company fully. But at the same time, the investors want the IP in-house before they'll invest. So there's quite a sort of tricky bit of chicken and egg going on with IP at the moment. And I think in retrospect, a bit of hindsight, I probably would have been a bit more hard-nosed in negotiating at the start. When we launched the spin-out from the university, I had lots of conversations about it. But if I was doing it all again, I would negotiate in a very, very different way than I did originally.
Investors want all the percentage of the whole company and all the IP in their hands to invest in. Universities are quite rightly going, hold on, you're working here or you're a PhD here when you develop this. We've supported you in it. It's not an easy circle to square. Yeah, and that's very normal for investors, isn't it? It's very, very normal. Since we're talking about investors, and the patents obviously are very, very important to them because there's value in that, where are you up to now with the funding of your company, and how have you bridged the gaps? There are grants, there's angels, there's VCs, you're hard tech, which means you do really need some cash to get going. How are you navigating that funding landscape, and what have you learned in doing so?
The investment journey really began, I would say, in September last year. I went to an investment event called Catalyst Inbound Investors, which I'm going to be going to again in September of this year. And that was my very first foray into having conversations with VCs and with angels, getting used to telling them about what the company is, what stage we're at, all that sort of thing, and really sort of dipping my toes in that. I actually got a lot of support, not only from Royal Academy of Engineering and from yourself, Neil, through the training that you've delivered through ChangeSchool, but also through Innovate UK's Investability programme. And we did a big blitz on this earlier in the year. Reached out to, I think, about 30 different investors. Some you just don't get a reply from. Some you get a reply from, which is, this isn't really our kind of thing. And then some you get a conversation with, and the conversation's usually been actually really quite fluid. Very good, productive, two-way conversations. Not just a flat pitch and a yes or a no. It's very much a conversation, which isn't what I envisaged it to be initially. But what we've learned from those conversations is that the energy modelling piece, until we've done that, we're not going to get any investment. So what the investors need is customer traction. But what the customers need is going to cost this much and save us this much. They need to have that quantified value. So the investors are basically saying, you need some customers who demonstrate that they're definitely going to buy this. I had one investor who said, come back to us when you have this on 100 buildings. And I'm like, okay, so if I'm going to put this on 100 buildings, somebody's going to have to pay for it to go on 100 buildings, which means I'm going to have to find the money from somewhere to pay for it, which means I need an investor to give me the money to pay for it, to trial it, with investors saying that they won't give me any money until it's been trialed. I think really there's going to be probably a hybrid strategy of grants enough to encourage investors to match fund, I think is where we're going to have to be with this. But underpinning the whole thing, we need to get the value of the product quantified.
There's quite a few catch-22s as you go through this process. You can't get the money until you've proven you've got the customers buying it, but you can't build it for customers until you've got the money. And again, it's not unusual, right? This is a normal story. And I guess it just serves to highlight how important that government support is to get you over those chasms and get you into the space where an investor will go, yeah, okay, let's do that. We've heard from other people how they're balancing the grants and the angels and the VCs, all of which are different beasts, to get them to the next step. And that business-focused, quantified value proposition, people don't know if they want to buy it or not.
Yeah, I mean, it's interesting, actually. You just thought of the amount of money we need is too big for angels. The VCs are saying you need to trial on 100 sites beforehand. So we're stuck in this valley of death halfway between we're too big for the angels and too small or too early for the VCs. Either we've got to find a corporate investor who really knows building facades and insulation and sees the inherent value in what we're doing and bankroll that transition. Or we have to keep on this path of grants until we've proved enough to get a VC on board.
Yeah, and this is the journey. Enough cash for the next milestone. How do you deal with the knockbacks, the stresses, I've got to February until, then I've got till June until, then I've got till December until. How do you deal with that as an entrepreneur?
I think when you have knockbacks from investors, you tend to learn more than when you get knockbacks from grants. When you've had a conversation with an investor when they're telling you, this is what I need in order to be able to invest, it's quite a focused way of finding out, where they think you need to go. So I try and use it as a learning experience. What actually spurred me on to do this in the first place is having a real gut feel that this can make a big difference in the world. That still is what fundamentally drives me forward to keep going with that journey. So I think if at some point I lose that, it'll all be over. But right now, I'm still a massive believer in what we're doing. So that sort of spurs me on to keep it moving. But it takes a lot of time. That's one thing when I started on this journey I didn't really appreciate, is just how much of my time is spent looking for money rather than doing the technical work, which is what I've spent most of my career learning how to do well. It is quite perverse in some ways. The things that I know how to do well and I'm adept at are not the things that I spend my time doing. I spend my time doing the things that I have relatively little experience doing. But the money has to come from somewhere, and someone's got to do it, and it falls on my shoulders. That's how it is.
You mentioned two things that are really important. One is that I'm still here doing the same thing I wanted to do. I still believe in it, and that's what keeps me going. The other thing you said is you got to take it as a learning experience. Once you've got past the, can I talk to this investor, they'll talk to you, they'll tell you stuff. You'll learn from those conversations. Doesn't necessarily mean they'll give you money, but there's something to be learned from that.
Yeah, it clearly is. If I'm getting told the same thing several times, it reiterates what I need to do. But after a while, you start to think, well, I'm being told the same thing again. What I need to do is stop seeking out and spending the time talking to people to get the same answer back again and actually solve the problem that I need to solve to move myself on. It's iterative, but knowing when to stop just constantly spending all the time seeking out new investors, knowing when to switch from that mode back to, right, let's go back into dealing with answering the problem. Constantly switching between those two things is quite tiring mentally. It's switching between engineer head to entrepreneur head, and then back to engineer head, and then back to entrepreneur head, because they're quite different mindsets in how you think. Very logical, evidence-based engineering head on the one hand, and a very optimistic salesman-like entrepreneur head on the other hand. Those two different heads sort of turn away from each other quite a lot of the time. A two-headed monster.
Well, that's what you do as an entrepreneur, right? Whatever, if there's nobody else to do it, it's you, and you've got to be able to wear those many different hats. You're not in a box anymore. You are dealing with life as it really is, the complexity, the changeability, the different demands that entrepreneurs do, and they umbrella their organization and actually protect some of the people inside that to focus on one or two things.
Yeah.
That's the skill. You talked about doing ICURE. Lots of conversations, learning from these conversations, getting some encouragement. You talked about building at the university, your prototypes and how important prototyping is. And you talked about your use of grants to get that moving. Let's take out this next step. So you're building a business-to-business hard tech product. How do you identify your customers? How do you get to those first meetings to validate that their need and that the customer need?
The construction industry, the customer is inherently a composite. It's not even one company who is the customer. There's the end payer, right? The end payer is the person paying for the building to be built. So it might be, in the case of the university building, this new campus building that I'm in at the moment, the university has borrowed the money and they are commissioning a design team, a contractor, to deliver them a building. But they have very little to do with its purchase, and they don't have scrutiny over every single one of those bits. They take recommendations, and those recommendations come primarily from the architect and the architect's design team, the facade designer, the building services engineer, the structural engineer, who are setting the specifications and drawing the drawings and doing the energy modeling. They're the ones looking at that component level specification. And that's why most of our sort of conversations have been with the design team, because they're the gatekeeper. That specification goes to a contractor. The contractor is ultimately paid by the building developer. The contractor primarily will do what they're told in the specification, but if they can find a cheaper way to do it, they then flag that up to the client and the design team, and they say, look, this is too expensive, why don't we use this instead? On something like the facade, there's always usually a specialist subcontractor, and primarily the facade contractor's got one huge role in that building, which is to make the building watertight. So they're often paying the suppliers of those individual components. So the facade contractor is our customer, but they're not specifying our product. Our product is still specified by the architect and the facade engineering team. So we've got a composite customer, the gatekeeper being the architect and their design team, our immediate customer being the facade subcontractor, and the ultimate customer being the owner of the building. There's another customer in there as well, which is the end user of the product, i.e. the person that sits in the building and does their work or goes to sleep or has a hotel room or whatever. They're the end user. They benefit from the product in the sense that the environment they're in, the thermal comfort of that environment is heavily influenced by our product. If we get it wrong, they suffer. If we get it right, they benefit in terms of comfort, but they also are paying for the heating bill or the cooling bill, and they also may be responsible for maintaining the building. So the end user is in that composite customer as well. So yeah, it's a difficult customer ecosystem to navigate, and most of our conversations have been with the designer specifier end of that conversation. We're starting to move more into talking with facade contractors because we're getting to the point where we've moved out of the lab into outdoor trials. We're now going from outdoor trials into trying to get into engineered into facades of buildings. So therefore, we need to facade contractors to actually deliver our component as part of a bigger system. They're the next element in our customer journey at the moment.
So your customer that you thought was your customer wasn't the customer, and you go down in the value chain and work out who the customer is. And then you go back up and go, but hold on, who influences that customer? How do they take their decisions? Who else is involved in the decision? And it's a very B2B process, right? There's always a decision-making process around B2B work, even in an individual company, let alone what you're talking about, which is across different companies that all working together to create what is a complex thing, which is a new building.
Yeah.
Some good lessons there. The customer isn't always the customer you think it is. You've got to go find it. So, given all that experience you've been through now, and given all of that knowledge you've gained over the last 2 or 3 years, and you've said a couple of times, "Oh, look, if I did it now, I'd do it different." Of course, you would as you go along and as you learn. So, given that whole process you've been through over the last few years, is there a decision you can think of that you would say, "Look, if I could go back and change that, I would"?
Timing of when to spin out, I think, is an interesting one. The argument for spinning out earlier would be that we would have had a lot of the commercial learning earlier, and I think it would have changed the order in which we've done the research. It might have slowed the process down because having spun out, the amount of time I spend on funding and engaging with investors takes away from the research. So it would make the research more efficient, but probably slower. If I spun out later, some of this technical challenges would be fixed, which would then mean that you could go to investors with something more ready to go and go to customers with something more ready to go. So depending on how you look at that, I could either be saying I should have spun out earlier, or should be saying I should have spun out later. So all of the commercial outreach and investor outreach that I've done in the last year, 2 years, I think that should have been done earlier. But I would have only ever been able to do that if I'd, let's say, had a grant to support me doing that was long enough to do that work properly and to fund that. Yeah, I'm talking myself into I should have spun out earlier. Should have spun out earlier, but with funding to support that. You need the impetus to go out and talk to investors and talk to customers, but without the hassle of having to constantly chase the money.
Well, from any university, I've got these advantages. From outside of university, I've got these needs. But you've got to cross that boundary. There is a point at which you have to cross a certain boundary. That needs certain things to cross that boundary, and that boundary is the spin out. And therefore, you've got almost some binary choices to make.
Yeah. Yeah, I mean, I think the big benefit of a spin out, you've got agility to make decisions quickly, to deploy money on something quickly, to hire somebody quickly, to buy a thing, pay a consultant. You get things done on a sort of much more commercial, responsive timescale, which just inherently universities aren't very good at. But you've also got the instability of how is that company funded? And if you're within the university, okay, there's grants come and go, but universities are a sort of big bit of inertia that sort of can see you through those sort of holes, which a spin out doesn't have on its own.
As we know, most of what we know about entrepreneurship these days comes out of the United States. They've done a lot of work on it and they've written the playbook. Is there anything you've learned in that process that has been counterintuitive, that's gone against the grain, that hasn't gone with what you would expect or what the playbook would expect or tell you today?
I think it's about timing, and in this time, rather than me focusing on where money's coming from, I'm going to focus on what a team should look like. I think the sort of classic approach to team is very heavily weighted towards business development and sales and marketing. Sort of the classic Silicon Valley type approach is that you've got a lot of you generate a lot of noise. You've got to sell something a long time before it's ready. I think that works in the software environment where you can sell something before it's ready because you can deliver it. With deep tech, that's not the case. So there's a big danger in overselling and having too much focus on marketing something that doesn't yet exist. People see through it, right? They know that the time frame for creating a new product in the construction industry is really long. So that focus on business development, sales and marketing in that classic Silicon Valley model, there's far too much emphasis on that. I tried to get business developers on board. I spent money on branding. I started trying to get my business developers to act like a sales team and go out and call people. But what actually happens is you just end up with lots and lots of leads, but I didn't have a product to sell. So a lot of effort went into that sales activity far too early. There was obviously some benefit of that because it got me leads of people to talk to about what the product should look like, but it was more than was needed, and because we're too far away from turning that into a saleable product, it's peaking too early, and I don't think that works quite as well for the deep tech.
Yeah, I think you're right, because if you're trying to actually go into a proper sales process, but you can't deliver a product for 5 years, you're not going to get anywhere, and you're wasting your time, and you're going to probably hurt your own reputation. Whereas what you were talking about before, about, well, hold on, but I'm talking to these people that could be customers in the future, but I'm validating their problem and I'm validating what's going on. And I'm seeing, how do I build this technology so that, and how do I demonstrate to venture capitalists that this is going to work? That's useful. You can't then sell them anything. There's nothing there to sell you.
Yes, absolutely. And I think the balance of resource needed for that is very different. Most of the successful activity in that customer outreach has actually been through myself and Mervyn directly having conversations, rather than us employing business development people to have those conversations.
Thinking back again over your journey, was there anything that you would recommend to another academic founder, a spin-out founder, that a book, a paper, a tool, or something that said that you would say really helped you and somebody following in your footsteps should possibly look at or use?
Right. I have to do the sales pitch for the Royal Academy Enterprise Fellowship at this point. The training I've had from the Royal Academy of Engineering Enterprise Fellowship has been really the thing that stimulated and coalesced all this stuff. So for me, that getting the Enterprise Fellowship was really pivotal in making this work. Rather than me identifying a book or a particular sage who's out there with particular advice, the whole cohort approach of the Enterprise Fellowship has been really, really useful. And just that training sessions spaced out over a 6-month period as a touch point to come back and see, right, where am I? Build the skill base a bit more, go away, do some stuff, come back, touch point again, build on that skill base. That's been really pivotal. In terms of a tool, ChatGPT is starting to become a part of my life, where I'd sort of been quite reluctant to use that previously. I'm sort of starting to use that a lot more. And another tool is Trello. So right back at the start of the Royal Academy training, you guys introduced me to Trello. I now use that on a day-to-day basis for managing tasks across our whole team. So that's definitely a tool I would recommend to anybody.
And thank you. And shout out to John McIntyre, who introduced all these agile processes. It is a very useful tool. And absolutely, let's give a shout out to the Royal Academy of Engineering, because they have done for something like 15, 20 years, they've been a massive supporter of engineering, entrepreneurship, and innovation in the United Kingdom, and really do support the ecosystem and make it work in a way that is really impactful. So, future, road ahead. So, in the next 12 months, I mean, you've talked a lot about the quantified value proposition. What do you reckon is going to be the most exciting milestone for you in the next 12 months?
The next big milestone, which we're planning to have in spring of next year, is to actually get 5 meters squared of our panels onto a real building, primarily with the aim of demonstrating what our benefits are in terms of reducing overheating.
That's a great milestone, because it really demonstrates what your product does. So you're at this critical stage. You've got 8 months runway left, something like this. You want to set these trials up. You're working on that quantified value proposition for investors, for potential partners, any of those people listening right now. What is the challenge where our audience could help you?
Well, I'll pick 3 challenges, if I may. So one for each of those stakeholders that you've mentioned. So right. to any investors that are listening, please talk to me. If you're interested in investing in switchable insulation, come talk to me. We're sort of really interested to sort of make connections at the moment, whether you're on the angel end of the amounts of money or you're sort of corporate investor on bigger amounts. Happy to have conversations at either end. We've got our SEIS advanced accreditation going through at the moment. So yeah, any investors would love to talk to you. In terms of potential partners, if there's any construction companies out there, particularly architects, facade engineers, facade contractors, give us your problems. We'd love to talk to you. We've got the ability now to do energy modeling of a building, or to take an existing energy model that somebody else has created and actually investigate what the benefit of switchable insulation in that building would be, and give some indication of what the costs of installing it might be, what the benefits over the lifetime of the building would be in terms of energy costs and comfort for occupants. We've got the modelling skill in place now to do that. What we really need are those real building examples. And in terms of future employees, if anybody out there has commercial experience in the construction industry, preferably a woman. Our team is very male dominated. Love to bring on some women with commercial construction industry experience. Anybody who has that experience of working in selling, particularly facade products, but any other building products into the industry, and understands that complex customer ecosystem that exists in the construction industry, and experience of navigating that and selling to people. We'd love to hear from you. That is really what we need to expand our team at the founder level, at the director level of the company.
Lovely. So investors, construction partners, and business development and commercials, particularly female. Fantastic. Finally, Adrian, where can our listeners go to follow your journey and learn more about switchable insulation?
So our main outlet is through LinkedIn. So you can find us at Switchable Insulation on LinkedIn. We also have our website, which we update regularly, switchableinsulation.com. And if you contact us through switchableinsulation.com or through the LinkedIn, we have a newsletter list that we maintain, and we send out newsletters every sort of 2 or 3 months just to keep people abreast of what we're doing, and we'd love to hear from you.
And if any of those partners are listening to this and thinking, I want to get in touch with Adrian, how do they do
that? Probably the best thing is to email me. So Adrian Pugsley, ADRIAN PUGSLEY, it's a long one this, at switchableinsulation.com.
Adrian Pugsley at switchableinsulation.com. All those details will be in the show notes as well. Adrian, it's been great having you on. Thank you so much. Warts and all is what it was, and it's so valuable for people to hear what it's really like as you're pushing through and building that company. So thank you very much for coming on here today.
Thanks for inviting me, Neil. It's been a pleasure. Thanks very much.
Absolutely lovely to see you. Ladies and gentlemen, thank you again to Adrian Pugsley, founder of Switchable Insulation Innovations Limited.